Hey guys, I'm going to be solving this question which says a soccer goal found in a city park. Basically, all of this is useless. You can read it. It says the area is given here by giving the height and the width. Um, the uniform electric field with a magnitude of 0.1 Newton per coulomb passes through the goal from the front to the back, entering at 90 degrees to the plane of the goal opening. What is the flux through the net? Quickly drawing the rough shape of the goal is going to be like this. It tells us an electric field is entering at 90 degrees through the opening of the front. Now we have to figure out how much flux will leave through the back. Gauss's law states that on a Gaussian on an object which is a Gaussian object, it has a Gaussian surface, which means it has a charge enclosed inside it which will be uniformly spread out. Let's realize that an electric field is passing through here, but there is no charge inside the goal, and Gauss's law states that there must be a charge inside the surface for there to be any flux. So the overall flux is going to be 0. We can utilize this to our advantage. We know that a certain electric field is entering to the front. Therefore, the flux through front must be equal to flux through back. Obviously, any flux that enters the surface here is going to be equal to this flux that exits through the net, because we do take objects when considering Gauss's law. So, a simple formula for calculating flux is Ea cos x. My E is 0.1, my area is 2.5 times 3.2, and cos 90. That's going to give you a flat value for the flux that exists through the net. However, in the next part it says find the flux through the net if the electric field enters at an angle of 60 degrees to the plane of the front of the goal. Basically, what it's telling us now is that instead of entering on simple 90 degrees, the field is entering on an angle of 60 degrees, but this 60 degrees is towards the plane, from the plane. So the 60 degrees is going to be this angle. This angle is 60. We have to realize that whenever we're dealing with non-linear or two dimensions, we can split any vector into its components. So if this is the flux, this is going to be the flux cos theta, and this is going to be the flux sin theta. Obviously, any flux on the vertical component is not going to be going through the net, it's rather going upwards. So the component that's going to be entering the net and exiting the net is going to be the horizontal component, which is going to be Ea sin 60, not cos 60, is going to be Ea cos 30. So this component is Ea sin 60 or Ea cos 30. So basically all I have to do is multiply this answer by cos 30.